Lesson 6, I will decompose fractions using area models to show equivalence. So this is a continuation of Lesson 5, where we learn to decompose fractions using area models and showing equivalence. We're going to be doing that again today. It says each rectangle represents one whole. Draw horizontal lines to decompose each rectangle into the number of units as indicated. Use the model to give the shaded area as a sum and as a product of unit fractions. Use parentheses to show the relationship between the number sentences. The first one has been partially done for you. Now, the first thing I'm going to tell you is we are not going to write all of this every time, okay? We're not going to write this every time. It is too much to write, actually, okay? I'm going to explain to you what they've done here, but we are not going to do this. First of all, they had 2/3, and they decompose it into 4/6. That part makes sense. So we had 2/4 and we decompose it into 4/6. So the first thing they did is they separated these 2/3 into 1/3 and 1/3. And then over here they said, well, each third is equal to 1/6 plus 1/6, because if you look at it like this is 1/3 and it equals 1/6 plus 1/6 plus 1/6 plus 1/6. So that's what they did here. Okay, so let me say that again. They took their 2/3 and they said, okay, well, 2/3 is the same as 1/3 plus 1/3. And then they said, well, each 1/3 is the same as 1/6 plus 1/6. So that's why these are in parentheses. And then that is equal to 4/6. Well, then they took these in parentheses and changed them into a multiplication sentence. They said, well, instead of writing 1/6 plus 1/6, we can write 2 times 1/6 to represent this. And then to change this one, we can change it into 2 times 1/6, which is equal to 4/6. And then they said, well, instead of writing this twice, we can say 2/3 is equal to 4 times 1/6, which equals 4/6. We're going to skip this whole step here just because I think it's too much writing and it's a little bit confusing. I think we can understand this without that step, so we're not going to be using that. All right, so let's take a look at the first one. So we have fifths. So we have 2 out of 5. And this tells us how many parts we're going to break it down into. Well, if I'm going from fifths to tenths, that means I only have to decompose it one time. So I'm going to cut each of these pieces into half. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of 2/10, I have 2/5, I have 4/10. So I've got 2/5 is equal to 4/10. 2/5 is equal to 4 times 1/10, which equals 4/10. So we're going to skip all that 1/10 plus 1/10 plus 1/10 plus 1/10. Instead of writing this 4 times, we're just going to say it's the same thing as 4 times 1/10. All right, let's take a look at 12ths. So again, let's take a look at the fraction that we have already. We have 1, 2, 3 out of 4. So let's label this 3/4. And this tells me I need to break this down into 12 parts. Well, if I just draw one horizontal line, it's going to be eighths, and that's not going to be enough. But if I draw 2 horizontal lines, now instead of 8 pieces, I have 12 pieces. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there are 9 of them. So I have 9 twelfths. So 3/4 is equal to 9 twelfths because 3/4 is equal to 9 times 1/12. If I went through here and counted, there would be 9 1/12ths, so it's 9 twelfths. All right, let's take a look at number 2. This time we have to draw our own area models. Draw area models to show the decompositions represented by the number sentences below. Express each as a sum and product of unit fractions. Use parentheses to show the relationship between the number sentences. So again, we're not going to do all that because it's asking us to write those same number sentences that down the front, and we're not exactly going to do that. All right, so let's go ahead and let's draw our area model. So remember, an area model is a little bit more squarish than a tape diagram, so I'm going to make it taller. And I'm starting with 3/5. So that means I need to divide this area model into 5 parts. I'm going to try to do this as evenly as possible. If I'm going to make this 5 parts, that means I'm actually drawing 4 lines. And once I do, I'm going to go back and count and make sure that I have 5. I have 1, 2, 3, 4, 5. So again, it's not exactly perfect, but it's close enough. Now I'm going to shade 3 out of 5. Remember, when we shade lightly so that we can still see everything. So I've got 3 out of 5, like this. And now we're going to decompose this into 6/10. So go ahead and pause the video and see if you can't decompose this into 6/10. Okay, so hopefully you figured out that in order to go from 3/5 to 6/10, all you had to do is just draw one horizontal line. And if you go through here and count, you will now have 10 parts. So let's go ahead and label the top of this as 3/5, and then we decomposed it into 6/10. Okay, now we're going to write this as an equivalence here. 3/5 is equal to 6/10. We know that 3/5 is the same as 1/10 plus 1/10 plus 1/10 plus 1/10 6 times, but instead of writing that sum, we're going to skip to this multiplication sentence and say 6 times 1/10, which equals 6/10. All right, now let's take a look at B. So we've got 3/4 is equal to 6/8. Why don't you pause the video and do as much of this one all by yourself as you can. If you get stuck, you can always press play. If you do it wrong, the worst thing that happens is you have to erase. That's okay, you learn from that. So go ahead and pause the video now and try to do as much of this as you possibly can by yourself. Okay, so hopefully you got most of this finished. You should have started out with your area model like this. We have to begin by decomposing this into fourths to show 3/4. So I'm going to start by going in half, and then I'm going to divide each half in half just like this. Oops. Hopefully yours turned out a little bit better than mine. Mine didn't quite make it, did it? All right, so I want that to go all the way to here. Now I'm going to shade 3 out of 4. So here I go, shading 3 out of 4. So remember, we're only shading this very lightly. We don't want to cover up the lines that show where we decompose this into fourths. All right, so there's my 3/4. Now I have to decompose these 3/4 into eighths. Well, to go from 4 pieces to 8 pieces, all I have to do is divide this in half. So that's what I'm going to do here. I'm just going to go right down the middle and divide this in half. So now I've got 3/4 is what I began with. So I'm going to go ahead and label that at the top. I started with 3 out of 4. And I ended up with 6 out of 8. And then let's go ahead and write this as a number sentence. So 3/4 does indeed equal 6/8. 3/4 would be the same as 1/8 plus 1/8 6 times, but instead of writing that, I'm going to write 6 times 1/8, which means 1/8 6 times, which is equal to 6/8. All right, last one. Draw an area model for a fraction with the denominator of 3, 4, or 5. Shade in more than one fractional unit. Partition the area model again to find an equivalent fraction. Write the equivalent fraction as a number sentence. If you've written a number sentence already on this problem set, start over. So it's always good to read all the directions before you get started. So I don't want to do something that's already on this problem set. Well, when I go back and look at the problem set, I have used 3/5, I've used 3/4, I've used 2/5, I've used 3/4, and I've also, let's see, have we used any thirds? Okay, so I have to draw an area model for a fraction with the denominator of 3, 4, or 5. I think I'm going to stick with thirds because we haven't used very many thirds. So let's go ahead and do that first. So draw an area model, and I'm going to use thirds. It says the denominator of 3, 4, or 5. Well, the denominator is the bottom number of a fraction. So that means that you're either going to divide this into thirds, fourths, or fifths, and I'm going to stick with thirds. So I'm going to go ahead and divide this into 3 parts like this. So I've already done step 1. I drew an area model for a fraction with the denominator of 3. Now it says shade more than one fractional unit. So let's go ahead and do that. I'm going to choose to shade 1 like this. Oops, that didn't turn out right. All right, I want to shade this. So let's go back up here and change this to highlighter. I'm going to shade 1. Now it says partition the area model again to find an equivalent fraction. So now I'm going to decompose. Partition means to just break it apart. I'm going to decompose this actually into 3 parts like that. So I started out with 1/3, and now I have 1, 2, 3 out of 9. Write the equivalent fractions as a number sentence. So I've got 1/3 is equal to 3/9. 1/3 is equal to, I could say 1/9 plus 1/9 plus 1/9 3 times, or I could just say 3 times 1/9, which is equal to 3/9. All right, so we have spent this entire lesson talking about equivalent fractions and how you can take an area model and you can decompose it into parts. In every single one of these area models, you'll notice we never went back and shaded in more. We always began with a shaded portion, just like right here. I shaded this. I never went back and shaded more. I never erased any. So our fraction stayed the same. It was the exact same amount. We just broke it into smaller pieces, just like if you had a cookie and you broke it into 3 parts. It's still the same cookie. The cookie did not change sizes. You just broke it into parts. So that's why these fractions are equal. They're just different amounts because the pieces got smaller. So we will continue to add on this concept in the next lesson.